In this video, I'm going to go through question number 1 from the projectile motion questions. We're starting to combine both our SUVAT equations for acceleration, as well as some of the vector work we did earlier in the year. Okay, so for this question, we've got a ball being kicked from the horizontal at an angle of 28 degrees. So that means that that velocity has, some of it is going to be in the horizontal direction, and some of it is actually going to be raising the ball up into the air in the vertical direction. And that gets really important because if you remember, vertically we have acceleration because of gravity, but horizontally we don't have any forces. Right now we're ignoring air resistance or anything like that. So that means horizontally we have constant speed, but vertically we have acceleration. And that also means we get our parabola shape. So in this case, horizontally, we're going to be moving a distance of 24 meters, and it says it's going to take 1.5 seconds to do that. Remember, the time is going to be the same in both the vertical and horizontal directions. And since this is a constant speed horizontally, I can just put those together, d over t, 24 divided by 1.5, and that gives me 16 meters per second. But remember, that's just in the horizontal direction. So I can draw that on my diagram right here as 16 meters per second. And part B, show that the vertical component is 8.5 meters per second. Now in the question it says show that, you don't get to use that 8.5. You actually need that to be your last answer or last piece of work. Now let's think about this. In this direction we had 16 meters per second. Here we have the actual velocity, and we have 28 degrees. Now, we know that this is the x component, and the y component would be right here. And when we're working with vectors, this is actually a rectangle. So even though the y component is right here, it's going to be the same as right here. There are a few different ways you can do this. One of the things I said in class is you could have started with here and used this side to find the hypotenuse here, v, and then go on and find the y component. Or we can go ahead and say, compared to 28 degrees, we're looking for this opposite side, and I know the adjacent. Opposite and adjacent, that's tan. So if I write my trigonometric ratio there, tan of 28 equals v, the y component, which is the opposite, divided by the adjacent, which would be 16. Now if I rearrange that and get vy all by itself, that is just 16 tan 28 degrees. Make sure your calculator is in degrees and not radians. Now, when I put this in my calculator, I get 8.507. Remember, all those numbers there only have two significant figures, and my math can't make my measurements more perfect. So when rounded, I get the answer I'm looking for, 8.5. And on to part C. Calculate the time taken for the ball to reach its maximum height. So again, this is vertical. That means I must be using acceleration in that direction. Okay, so I'm going to write my SUVAT to begin with. And let's think about all the different values we have. Since it's vertical, I know my acceleration is going to be negative 9.81 meters per second squared. It's going to go all the way up to the top, which means its final speed is going to be 0. I like that. That makes my algebra so much easier. And my initial speed is going to be that 8.5 meters per second. Notice that even if I didn't get part B, I could still go on and solve C. That's one of the reasons we have these kind of show that questions, so that even if you get stuck, don't give up, go on to the next part. Okay, and what am I looking for? I need a question mark somewhere. Ah, the time taken. So I need the equation that has these four variables. So I go and I look at the list, because remember, you don't have to memorize them. And I need the one that has A, V, U, and T. This is what it looks like. I'm going to go and, 0. Put a big arrow through, mark that out. And now my algebra is really easy to move around. T is going to be negative U over A. Now I'm going to put those numbers in, negative 8.5 over, and remember A is a negative value, negative 9.81. And when I look at my calculator, I've got decimal 866462793068298. Remember, don't write all the decimals down. Look at all the numbers I have here, and they have 2 or 3 significant figures. So please then round to that. Ideally, since the smallest number of significant figures I have is 2, I should round at the end of the question to 2 significant figures. That would give me 0.87 seconds. And finally, how tall is the wall? Again, this is a vertical motion, so we know we're going to be using SUVAT and acceleration. One other thing I'm going to point out is we're going to be measuring from here upwards. Remember, since I'm going to be measuring upwards, my distance should come out to be a positive value. That's different than if I was doing a question when I was dropping something off a cliff. I would be measuring the height then from where I am in a negative direction, downwards, so I end up getting a negative distance. Okay, start off with SUVAT. So we know the time it takes from when I leave is 1.5 seconds. It doesn't matter horizontal or vertical. We know that time is going to be the same. It's vertical, so acceleration is 9.81 meters per second squared. And in part B, we know that the initial speed is 8.5 meters per second. Okay, now you might say, well, what about the other ones? And well, we're looking for the height. And the final speed, we don't know. And remember, this would be just the vertical component. So I would suggest it's not going to be something that's easy to calculate. Again, so I've got 4 different things in my SUVAT. Yep, good to go. One of them's a question mark I'll look for, and 3 other pieces of information I know. All I need is the equation that has S, U, A, and T. I hope you picked out this one. Now, I don't have any zeros in here, so I'm going to have a lot more math I'm going to have to calculate. Let's put in the numbers. So U, 8.5 times 1.5 seconds plus a half times, don't forget the negative sign, 9.81, and then times squared. Put it in your calculator, and hopefully you're going to get the same answer I do. Push pause, make sure you can get it yourself. Okay, so my calculator gives me 1.71375. Again, I look at the numbers and they all have 2 or 3 significant figures, so that's all I should have in my answer. And I'm going to round it to 2 because my values, I have the least number of significant figures there. Oh, by the way, never round to less than 2. It's usually a good bet if you're going to choose 2 or 3, you're almost always going to be right. And I'm in meters. Stop and think for a second. Does it make sense? 1.7 for a wall? Yeah, that seems about right. I hope this helps you out, and I hope you stop and rewind and go through as many times as you need to so that you can see how we can separate horizontal and vertical motion. Now we're moving in 2 dimensions.